Hi, my name is Craig. I'm a senior lecturer at the University of Glasgow, and these tutorials are designed to help you get the best out of your image data using ImageJ and other related software. Today I'm using Fiji to demonstrate some of the features of Volume Viewer for visualizing 3D image volumes. So let's get started. Fiji is really just ImageJ, and that's what the name means. Fiji is just ImageJ, F-I-J-I. And one of the advantages of Fiji is that it has lots and lots of plugins. It comes ready populated with loads of plugins, more than you would probably ever need to use. But it's particularly good for 3D Viewer and Volume Viewer. Good for 3D Viewer because it comes with a Java environment, or it installs Java when you install Fiji. And that can be quite tricky when you're using ImageJ. So they're effectively the same program, really, just packaged very slightly differently. Okay, so we're going to be using Volume Viewer, but first of all we need to set up our volume. I'm going to use a 2-channel volume today. So I'll bring my data in. Got 2 channels, 2 data sets. Obviously bits of blood vessel because that's what I do. Over here in the green channel we have some smooth muscle cells. And it's a Z series from confocal microscopy, so you see that there are a series of images that go down deep into the sample. They start to fade as they go down deep. And here are the nuclei of those individual smooth muscle cells. So the first thing that we really need to do is to check the properties, make sure the ImageJ's got the right sizes. So we're going to find somewhere the image properties. Here we are. Tells us that we've got one channel here. It's the smooth muscle channel, the green channel. It's 45 slices. Importantly, what I'm looking for here is that the pixel sizes are correct, and more importantly, the volume depth. These slices are 0.5 microns apart down through the Z-axis. Okay, so that green channel is okay, and the red channel properties, it's fine, 0.5. Okay, let me just put this to the side for the moment. I want to show you the orthogonal view. So I go to stacks and orthogonal views. Now you'll notice if I put this up here, that as we go down through the depth of the data, it gets darker and darker as the laser starts to scatter and presumably some photons are absorbed. But it's really not as strong as you go deep down into the specimen. We can fix that by enhancing the contrast. So we go to Process, Enhance Contrast. We want to normalise all the data, and we want to use all 45 slices. And when it goes through this algorithm to normalise the intensity, it may saturate some of the pixels. That is, that some of the pixels may be given a value of 255 or greater. Remember, in an 8-bit image all the values run from 0, which is black, to 255, which is the brightest. I'm happy for maybe 1% or so of my data to be saturated. Okay. Watch what happens in the orthogonal view. Right, corrects it very nicely. Let's do the same for these nuclei. Bring up the orthogonal views just so you see it. Okay, so you'll see that as we go down deep, we lose the nuclei. We go to Process, Enhance Contrast, normalise all 45 slices with 1% saturation, okay, but not bad at all, that's good. Okay, so we've got our 2 channels, and I probably would want to merge these 2 channels. So I go to Image, Colour, Merge Channels. My green channel is my smooth muscle cells. My red channel are my nuclei. Keep the source images just in case something goes wrong. Okay, and then I've got my composite. I will remove my original images. So we've got a nice composite image where you can see the long, thin, green, smooth muscle cells with the red nucleus, the cell nucleus, pretty much in the centre of the cells. I want to make a volume of that and then animate it. So let's go into Volume Viewer. Go to Plugins, Volume Viewer. Okay, now what we notice as soon as we get into Volume Viewer, if we look at the slice window here, is that as we go through the slices, you'll see that it brought in the two channels alternately, slice after slice, which is not ideal. I want Volume Viewer to have the merged data rather than two separate data sets. So let me just quit Volume Viewer and show you how we fix that. We need to make this data set a type RGB rather than two 8-bit channels. So let's make it RGB. And here we go. I'll minimize this. So now what we've got is an RGB data set. Let's throw that into Volume Viewer. I'll just pull scale out here. Now as you can see, it's come in as a grayscale. And I really want it to be green and red. So I need to change the lookup table. Come up here to my lookup tables and choose original. There we go. Now you can see that some of the data is missing. And the reason for that is over here. And I'll explain that in just a minute. First of all, what I want to do though is to look up at the different modes. The first one here is a slice mode. And the slice mode, as you'll see, just gives you one single slice through the whole data. And I don't find this to be particularly useful. Well, I haven't found a use for it. And put the borders round, and you start to see a little bit of the thickness of the data. You can see more that it's a volume as we get these orthogonal slices through the data. That could be quite useful if you were looking for a feature sort of deep within the data somewhere. Maximum projections. I had another video which shows you how to make a Z projection, and that can be quite useful. It just shows you the Z projection at different angles. There's another projection type, but we're here to look at the volumes. Okay, so in the volume, what we have is two channels. We've got a red channel, a green channel, and we have no blue channel. Now in the red channel, let me first of all just fix this so we can see all the data, and I'll come back and explain what I'm doing here. Okay, so here's my whole data set. You can see the individual cells quite nicely. Now I can play around with my red channel. See here, what I can do is I can change the brightness or the intensity, the contrast, by changing the shape of the red channel curve. And I can take in more red. I can pull it back. So probably what I want to do, and for every data set it will be different, I probably want something like that. For the green channel, maybe something similar. That's maybe too much. So you can play with the lookup table intensity here. Down in this panel here, what I want to show you, we'll come back to this, is this opacity curve. I'll just show you what these other panels are while we're here. It helps you to select the data. As you can see here, it says pick an alpha value, which is a transparency and a colour, and draw in the 2D transform function. So let's say I wanted to make these particular intensities here quite opaque, then I would make this more opaque, and I would just paint in here what I want. If I wanted the darker stuff, I can paint this in here. And you use Alt, click to get rid of that. This shows you basically the same function, but in a slightly different way. I can start to paint in the data that I want depending on the intensities. You see the data starts to come in. And for the 3D fill, this is like a seed fill. It's not too bad. What it allows me to do is to come over here to the slice window and pick a particular intensity. So let's see, this is very bright here. If I choose this, what it will do is it will select the pixel of that particular brightness that I'm pointing at and all of the connected pixels of a similar value within a particular tolerance range, so sort of plus or minus. And if I put the tolerance up, see what happens. Bring in more data. So you can use this, the combination here of luminescence and gradient tolerance to pick out different intensities within the volume. And you can spend quite a bit of time trying to get that just right. But let me go back to the opacity table here and show you what's going on. This black peak that you see here is the histogram of the entire Z series. So what it's telling me is that within the full Z series there are not a lot of black voxels. There are not a lot of very bright voxels, but there are a lot of these sort of low-mid range voxels. So that tells me about the spread of the data. This curve here tells me about the opacity of the data. If I make every single voxel completely opaque, right, so regardless of its intensity, it's opaque, then what you've got is a solid block. But really, I want to see the space between the cells so that I can see individual cells and maybe see connections between the cells. For that to work, I'm going to need to make the dark stuff, the very dark voxels, transparent. But I want the bright voxels to remain opaque. So I'm going to draw this curve, keep it high at the bright side, but as it gets lower, just pull this down here. As it gets to the black voxels, I want these to be transparent. And you can see the effect that that's had. You can see the background now through the volume. Let me just zoom that out a little bit. Now, you can spend quite a long time just getting the shape of this curve just right. And if you had two specific intensities within the volume, you might want to have little peaks. But you can spend a bit of time drawing this opacity curve. And I would spend some time with VoxelViewer shaving this ever so slightly and maybe just playing a little bit here with the intensities. Okay, so that's how we bring a volume into Volume Viewer and how we set it up as a volume. Now what if we wanted to animate this volume? Now unfortunately, Volume Viewer doesn't have an animation facility, but we can kind of make an animation by taking snapshots and then building a video from the snapshots. So I'm going to, oh I forgot, the lights. You can switch on the light and it gives you a different type of render where you can change the ambient light. how diffuse the light scatters, how shiny the volume is. And you would probably want to change this a little bit. And the result that you get here will be depending on how good your computer is, how much video processing, how much RAM you've got. Not too bad. But I think for this particular volume, this would work really nicely with the data set in which there was lots of space between the objects. I think for this data set, actually, I don't think that having the light on actually helps. You can of course change the colour of the light. Okay, let me take this back to front view. I'm going to hide this transform function window, so we've got a little bit more space. Okay, let's say I want to do a rotation around the y-axis or the x-axis. Let's go for the x-axis in the first instance. What I'll do is I'll take a snapshot, and then I'm going to rotate round by 3 degrees. So I'll go 1, 2, 3. Take another snapshot. And I find that if you go in 3 degrees, you will get quite a smooth animation. You could probably do 5, and it wouldn't be too bad. What you can also do here in the scale is you can also zoom in. So if you click, it moves up by, I think it's 0.3 or 0.5. I'll take it back though. Okay, so I've got 130 slices now. So let me just quit Volume Viewer and I'll minimize this. So I've got 130 images, and now what I want to do is to put them into a stack. So I'll do stack, images to stack. Keep source images, no, I don't need them. Click OK. Okay, and here's my stack. And if I play my stack, hopefully, it's quite good. And obviously I would want to save that as a video file. So I go to File, Save As, .adi probably. Compression 24 frames a second, and I've got 130 frames, so it'll run for a few seconds. Okay. Just save this on my desktop as Smooth Muscle Cell movie. Okay, here it's here, Smooth Muscle Cell movie, just run that. Okay. There you are, that's it, that's Volume Viewer. Hope you enjoyed that. If you'd like to learn a bit more about my work, then please check out the website at www.cardiovascular.org. And if you would like to watch some more image analysis tutorials, then please check out my YouTube channel, which you can also link to from the website.